Most finance professionals using AI right now are still prompting their way through every single step. Data cleaning is one prompt, structuring the tables is another, building the model is another, and the whole sequence has to be repeated from scratch every time new data comes in. Each step is faster than doing it manually, but you're still constantly repeating the same process. Claude's latest update allows me to build automated workflows that I can reuse for similar use cases, and this is an absolute game changer for finance professionals. It allows me to save more time on the executional work with AI and focus on decision making. So in this video, I'm going to show you how to build a full end-to-end finance workflow, and then I'm going to show you how to reuse the same workflow the next time data comes in without rebuilding anything. Now, if you want to use the prompts and the resources I use in this video, you can find them in my free community. The link is in the description. So let's get into it. The new Claude update. So before I show you the actual process, here is what actually changed. Claude now supports structured multi-step workflows that you define once and then you can execute repeatedly. Instead of prompting the AI through each stage of your use case one at a time, you write out the full logic of your process, the sequence of steps, the rules for how data should be handled, how the model should be built, what checks need to pass, and how the output should look. And Claude then follows the entire workflow from beginning to end in a single run. For finance, this is a significant shift because of how repetitive our work actually is. Monthly closes, quarterly reporting, budget versus actuals, forecast updates, investor decks. These all follow the same analytical sequence every cycle. You collect the data, you clean it, you structure the model, validate the numbers, run the analysis, and prepare the deliverable. The steps rarely change, but what changes is the data. And yet every cycle, most teams are essentially rebuilding the same analytical framework from scratch, either manually in spreadsheets or through a fresh set of AI prompts that may or may not produce consistent results. And this is exactly the kind of problem a reusable workflow solves. You define the process once, covering everything from how columns should be standardized to how margin calculations should be structured, to what audit checks need to pass before the analysis moves forward. Then when new data arrives next month or next quarter, you feed it into the same workflow and the entire pipeline executes again automatically. On top of that, Claude now operates inside structured project environments. So what this creates is something that functions more like an internal tool than a chatbot. The workflow file acts as your process documentation. The scripts folder holds your reusable logic. The reports folder contains every output the system has ever generated. And because all of this lives inside a normal file structure, it integrates with version control, shared drives, and whatever project management system your team is already using. That means the analytical process becomes auditable, it becomes portable and version controlled. You can hand the entire project folder to your colleague and they can run the same analysis on a different data set without needing to understand how the prompts were originally written. The logic is embedded in the workflow itself. Now let me show you how to actually build one of these workflows from scratch. The first thing you need is a clean project structure. So create a folder with 4 components: a data directory where your incoming spreadsheets go, a scripts directory where your reusable automation code gets saved, a reports directory where all generated outputs land, and a workflow documentation file at the root called finance_workflow.md. This file is the brain of the whole system. It defines what inputs the workflow expects, what steps it needs to run, and how outputs should be saved. Inside the workflow file, you specify your input expectations. The dataset needs columns for month, revenue, COGS, operating expenses, marketing, and R&D. Numeric columns need to actually be numeric, no currency symbols, and no text formatting. You also define the 6 stages your workflow will execute. And this is where the real power comes in, because each stage builds on the previous one, and the entire chain runs without you intervening between the steps. Stage 1, data structuring. The workflow starts by reading whatever spreadsheet is sitting in your data folder. It standardizes column names and data types, strips out any formatting artifacts that would break calculations, and then generates the derived financial fields for your model needs. Gross profit gets calculated as revenue minus COGS. Gross margin is gross profit divided by revenue. Operating income is gross profit minus operating expenses. The cleaned dataset either gets saved as a standalone CSV or it gets written directly into the datasheet of your output workbook. And the reason this matters as a defined step rather than something you just ask Claude to do ad hoc is consistency. Every time this workflow runs on the new data, the cleaning logic is identical. There's no risk of forgetting to strip currency symbols from one column or accidentally leaving a text field where a number should be. If you've ever had a margin calculation return an error because someone left a dollar sign in a revenue cell, then you know exactly why this kind of automated standardization matters. The workflow catches those issues before they propagate downstream into your model. Stage 2, model construction. Now, once the data is clean, the workflow generates a reusable Python script and saves it to your scripts folder. The script builds your Excel workbook with structured sheets for data, model, audit, analysis, dashboard, and report. The critical detail here is that the model sheet uses formulas that reference the data sheet directly. Revenue values link back using cell references, gross profit is calculated through formulas, and nothing is hard coded. So when the underlying data changes, every calculation in the model updates automatically. Now, this script persists in your project. The workflow checks whether it already exists before generating a new one, which means after the first run, the same model building logic gets reused on every subsequent dataset without being regenerated. And because the script is a standard Python file sitting in your project folder, you can open it, you can read the logic, and then modify it if your reporting requirements change. Now, you are not logged into a black box. The automation is fully transparent and editable, which is something that matters when your team needs to understand exactly how a number was calculated. Now, stage 3, model review and audit. This is the step that most people skip when they're using AI for finance work. And it is arguably even the most important one. Now, the workflow creates an audit sheet that runs diagnostic checks on the model. It verifies that gross profit actually equals revenue minus COGS. It confirms that margin calculations are consistent. It checks for negative revenue values, makes sure COGS does not exceed revenue, and flags any broken formula references. Now, each check gets a pass or a fail status with a short description of what was tested. And here is the key constraint. If any critical check fails, the workflow stops. It does not proceed to analysis or generate a dashboard on top of broken numbers. This is exactly the kind of safeguard that gets lost when you're prompting step by step, because there is no built-in gate between your model and your final output. Stage 4, financial analysis. Now, once the model passes audit, the workflow moves into the analytical layer. It calculates month-over-month revenue growth, it tracks gross margin and operating margin trends across the dataset, and breaks down cost drivers as percentages of revenue so you can see how COGS, marketing, R&D, and other operating expenses are moving relative to the top line. But it doesn't stop at the numbers. The analysis sheet also generates short interpretation lines that translate the metrics into plain language observations. So if revenue growth accelerated in the most recent month, that gets called out. If COGS is trending upward as a share of revenue, that gets flagged with context. Now, these interpretations feed directly into the executive summary, so the final report already has narrative built in, which is really useful if you're preparing materials for leadership or board presentations where raw numbers without commentary are not really that helpful. Now, after this stage is complete, you should spot check a few calculations manually. Pick a month, calculate the revenue growth by hand, and then compare it to what the analysis sheet produced. This takes 30 seconds, and it gives you confidence that the analytical logic is sound before you hand the output to anyone else. Stage 5, dashboard and reporting. The last building stage creates the visual layer. The workflow generates a dashboard sheet with charts covering revenue trends, gross margin trends, operating margin movement, a cost breakdown for the most recent period, and a revenue growth bar chart. It also produces a report sheet with bullet point insights summarizing the most important findings from the analysis. Now, these insights pull directly from the interpretation lines generated in stage 4. So there is a clear analytical thread from the raw numbers through the metrics, through the executive summary. After the workflow completes, everything gets saved to your reports folder, and the run gets logged with a timestamp, the dataset name, the output file name, and any warnings that occurred during processing. If the output file happens to be locked because someone has it open in Excel, the workflow automatically saves a timestamped version so that nothing gets lost. So at this point, you have a fully built workflow that took raw data and produced a validated model, analysis, and a dashboard. But the real value is what happens next, because this entire process is now reusable. So let's actually use the workflow now, and this is where the workflow approach pays off. The next time you have a new data set, whether it is next month's financials or a different business unit entirely, the process is the same. You drop the new spreadsheet into the data folder and you tell Claude to execute the workflow again using the data set in the data folder. Now, that single instruction triggers the full pipeline. The data gets cleaned with the same standardized logic. The model gets rebuilt using the same script that is already sitting in your scripts folder. The audit checks run against the new numbers, and the analysis calculates updated metrics. And the dashboard then regenerates with the latest trends. Now, you can see what is happening on screen right now. The same structured process that we built from scratch is running again on completely different data, and the output maintains the same quality and consistency because the logic hasn't changed. The only thing that has changed is the input. So this is where finance teams start to see real time savings. The first run takes effort because you're defining the workflow, you're setting up the project, you're structuring it, and you're making sure the logic is right. But every subsequent run collapses what used to be an hour or more of manual work into a single command. And the quality of the output actually improves over time because the audit checks and analytical logic get refined with each iteration. Now, if you notice that a particular check is too sensitive or that a cost driver breakdown will be more useful with a different grouping, just update the working file once, and every future run inherits that improvement. Now, once the workflow finishes, take 30 seconds to verify the output before you hand it to anyone. Confirm the data sheet loaded the new dataset correctly and the columns are formatted as expected. Check the audit sheet and make sure there are no critical failures. Scan the analysis sheet to see if the margin and growth calculations look reasonable against the raw numbers, and confirm that the dashboard charts are actually reflecting the latest data and not carrying over artifacts from a previous run. This takes literally less than a minute, and it gives you full confidence that the system processed everything correctly. And because every run gets logged, you have a complete record of when each use case analysis was generated, what data set was used, and what the output file was called. Now, if someone asks you 3 months from now how the Q2 report was produced, you can point them to the workflow file, the scripts, and the run log. And the entire analytical process is documented and reproducible, which is something auditors and compliance teams genuinely care about. Now, for finance teams that are running the same reporting cycles month after month, this eliminates the most time-consuming part of the process, which is rebuilding and revalidating the analytical framework every time new numbers come in. the framework stays in place. You just update the data. Now, if you want to use the prompts and the resources I use in this video, you can find them in my free community. The link is in the description below. This is where AI in finance is heading. The value is no longer in getting AI to answer individual questions or perform isolated tasks. The value is in building structured systems that reflect the way finance teams actually operate. Repeatable processes applied to changing data with built-in validation and consistent output formats. The workflow we built today handles a standard financial reporting cycle, but the same approach applies to budgeting, forecasting, operational reporting, performance diagnostics, anything where the analytical steps stay the same and the data refreshes. If you want to try this yourself, the workflow structure and the process we walk through are everything you need to get started. Set up the project folder, write your workflow file, run it on your first data set, and then see how fast the second run goes when the system is already built. Thank you for watching, and I'll see you next time.